In this video, we're going to solve a polynomial inequality using test points. We want to solve the inequality x minus 2 quantity squared times x plus 5 is less than 0. We first need to find the boundary numbers that will determine the regions of the number line from which we can pull test points. Boundary numbers are solutions of this associated equation. That is, we replace the inequality symbol with an equal sign and solve that resulting equation. So we want to solve x minus 2 quantity squared times x plus 5 is equal to 0. Because this is in factored form, we can set each factor equal to 0 and solve. So we get x minus 2 quantity squared equals 0, or x plus 5 is equal to 0. So the solutions are x minus 2 is equal to 0, or x equals 2, or x plus 5 equals 0 gives us x is equal to negative 5. So our boundary numbers are negative 5 and 2. And so this divides the number line into 3 regions. I like to label them A, B, and C. That is the region to the left of negative 5, which is the interval from negative infinity to negative 5. The region B is the region between negative 5 and 2, so negative 5 to 2. And region C is everything to the right of 2, or 2 to infinity. And now we need to test a point from each of these 3 regions. So a number inside region A would be negative 6 between negative 5 and 2. I always like to use 0 if it's in the region. And then a number to the right of 2 would be 3. And what are we going to do with that test value? We're going to plug it into the original inequality to see if it makes the statement true or false. So if we substitute negative 6 in place of x, we would get the quantity negative 6 minus 2 quantity squared times negative 6 plus 5, and we're asking ourselves, is that less than 0? Negative 6 minus 2 is negative 8, but when I square it, I'm going to get a positive number. Negative 6 plus 5 is negative 1, so I'm going to have really a positive number times a negative 1, which is negative 64, and that is a true statement. If we replace x with 0, we would have the expression 0 minus 2 quantity squared times 0 plus 5. Is that less than 0? Well, 0 minus 2 is negative 2, squared is 4, and 0 plus 5 is 5, and 4 times 5 is 20, which is not less than 0. In a similar fashion, we'll plug in 3. 3 minus 2 quantity squared times 3 plus 5. Is that less than 0? 3 minus 2 is 1, squared is 1, times 3 plus 5 is 8. But that's 8, which is not less than 0. And so what we learned from this is that the only region that satisfied this inequality is this first region A, which is from negative infinity to negative 5. So on a number line, we're going to shade the portion that corresponds to that to represent our solution set. We have to think about what happens at the end point, because the end point is where it equals 0, but we want to be strictly less than 0. We cannot include negative 5, so we'll put a parenthesis on negative 5. So the solution of this inequality is negative infinity to negative 5.